As you'll see in the next video, the method updateLocation, which is currently on the screen, is called every single time the location provider gives a location object to the app. We receive that location object and make sure that it's not null, and then we also check to make sure that we have the GPS fix, meaning that we're properly communicating with the GPS satellites so that we know we're getting good GPS data. Now, once we've determined that, we add the location as a point to our route overlay object, which is where we're going to draw the lines that represent the route that we're traveling, as well as some points every 10 locations to indicate positions along the route. And then separately, if there was a previous location, we add the distance between the current location and the previous location to our distance traveled, and we use the distance to method provided by class location to do that. Now at lines 147 and 148, we obtain the latitude and longitude for the current location, and we multiply each of these by 1e6, which represents 1 million. And basically what this does is it converts these longitude and latitude readings into what are known as micro degrees, and we need those because a geopoint, which we're creating here at line 151 and 152, requires the latitude and longitude to be represented in micro degrees. And basically what the geopoint does is it takes that GPS data and turns it into data that can be used with a map controller to position the map on the screen. So once we have that geopoint, we pass it to our map controller and we say animate to that point, and now what happens is the map automatically recenters itself to that geopoint. Then finally at line 158, we call our bearing frame layouts setBearing method, passing it the result of location.getBearing, which returns the direction in which we're traveling, and then we tell the bearing frame layout to invalidate itself, which is going to cause that to redraw. And at the end of the method, we store the current location in our variable previous location. Now, when you're operating within the AVD, the getBearing method does not give you any information that allows you to reorient the map based on the direction that you're traveling. However, it is possible instead to use a method named bearing2, and you can call that on the previous location object, passing the current location object as an argument. And if you were to use that method of determining the bearing, then you would actually get the maps reorienting properly even inside of an AVD.